Pretty much all here. If you left us for choir yesterday, the video is uploaded. We will be doing 431, but that's not what we're starting. So everyone can please, you can keep the class stuff on your desk if you want, but all you really need available right now is at least a half sheet of paper. It can be a full sheet if you want. Calculator, writing utensils. Then we are going to start by independently. What can I do? Because some people are still here. I'm going to take a screenshot of this, throw that up on the TV, and then screenshot of this. There we go. All right. Mr. Estes has received a letter offering him a job with NASA. This is not for real. He's not leaving you.
No.
But when talking with Mr. Estes, he actually said, depending on what he was doing, he might work there for free. Because I was like, what do you think like NASA would pay you? And he's like, man, they might not have to pay you. But so this letter, oddly enough, states that for every 6.5 hours he works, he's going to get paid $240.50. Somebody was getting creative with their letter writing, apparently. So we need to compute his hourly rate of pay using the y equals kx type formula once we figure out that rate of pay and figure out what he will make in a 40-hour work week. This is kind of driving me crazy that this is right here. That should go drop down to the next line. Y equals kx form. So essentially you need to solve for your k, then write your equation, and then calculate how much he'll make in a 40-hour work week. Go for it. You are working independently right now first. Do not open these. Do not do anything with these. You guys ready? Hey, we're taking a quiz. You also don't know whether or not this grade's going to match. You don't know whether or not I'm actually collecting this grade. If you have second AM, you can go ahead and start. Otherwise, how much more time do we have? A minute, 2 minutes, 3. Give me a finger count. Okay, let me give you 3 more minutes on the 15. Yes, I don't have the holding 15 now. 25 seconds. If there are 3 people at your group, you're going to do a rotation, either handing to the right or handing to the left. If there are 4, you can either trade with your partner or rotate or do whatever. Get a paper that is not yours. So trade with a neighbor. So get a paper that is not yours. Hey, we just learned this yesterday. It's totally fine. Not all of us are going to totally get this. We're going to use this as a growth experience. Okay, so at your groups, some people are going to be better than other people. So actually 4 groups of 4. There's only 2 of you. Never mind. I was going to say just trade so you can discuss with each other. Take 45 seconds to look at their paper. Don't say anything. Don't do anything. Just look at their paper. Look at their work. Then, if you were me having to grade this, take a minute to write some kind of feedback. If you think they did everything right, you can write great, you're awesome. If you think there's any mistakes, you can circle that or put an arrow to that or a question mark. If you want to talk with them and say, or like ask them a question, like a see me sort of situation, like, oh, hey, what did you mean here? Did you just not finish? Take a minute to do that. Then, when you're done, hand that paper back to its owner. Owners, hold up. Hold up. After looking at somebody else's paper and now getting yours back, take 45 seconds to a minute to decide if you would make any edits to your work or if it was all good or what you would do if you had that opportunity. It's about 45 seconds. All right, now we're going to go straight up cards for this. Delaney. Why are you guys laughing? It could be you next. Delaney, what does per tell me to do? Divide. So if we can realize that the hourly rate of pay, if I rephrase that, would be the pay per hour, then this per tells me to divide. Liam, what order or in what numbers am I going to do my division in? Okay, so like tell me what to divide by what. .5 divided by 2, why? So that's going to be 3.25 hours. It's a little weird still. Annika? You're right. So if you set up a table like we've been doing, when we have nice numbers that work really well with each other, if you set up a table and tried to like cut it in half or do things like that's not going to work very well. Pay per hour tells me what to do. Take your pay, $240.50, and divide that by the number of hours. This is why you have a calculator. You're not trying to do this in your head. You're doing this in the calculator. When we do that division, we actually solve what is the numerator when the denominator is 1. Dividing does that for us. Even if this is a weird number, it would still be that weird number over 1. What did you get, Monica? 37. Now, again, especially for the video, I made this up. I hope NASA pays better than that. Who knows? Mr. Estes' rate of pay would be $37 for every 1 hour. Now, like I said, Estes said he would probably work there for free. But then, Alan, how do we write this as an equation in that whole like y equals kx form? So we did this yesterday, right? We're working with the constant of proportionality equation, where k is our constant of proportionality. This is going to tell me my output will be something times whatever I put in, this multiplier. So this k should be a number. We got to replace it. What do we replace that with in this situation? You ask anybody? Yes! Our constant of proportionality here is 37 because we just calculated that. So we set up y equals 37 times x. If you don't have that, please write it down. Which really means his pay will be 37 times what? What will the input be? Well, so any hours, right? But in this next question, we're going to say his pay will equal 37 times, when he works 40 hours, then my input is 40. Please write this workout if you don't have this on your paper. 37 times 40. And in a week, if he works a 40-hour work week, his pay would be, Monica, you got it? What is it? Sorry. $1,480. Now I will tell you that's actually more than I make on a paycheck, which is 2 weeks worth. But that's taxes taken out. Like what I bring home is about $1,400 every 2 weeks. So I would totally take that. If I could make that in a week, shoot, I'd go work at NASA. It'd be sweet. My uncle actually used to work at NASA. Shoot things into space. Yeah, they do a lot of stuff, but yeah, that's what they're most notoriously known for, shooting things into space. All right, that paper is your reference point for a problem that I guarantee will be on the mastery. There's people talking over me. I guarantee you a problem very similar to this will be on the mastery. Please be ready for that. I would keep this paper if I was you. I would label the top of it mini mastery and go back and review it to study. We're going to use y equals kx form, but we don't always have to use y and x. You can change your variables. You can say pay is 37 times hours. You can make it more easy for you. So now, those tiles that I put on your desk, I need you guys to open those back. You need to keep these sorted, so I would share them by pairs. If you have 3 people, somebody gets their own bag. I would share them by pairs. You don't mix up tiles, please. You also, hey, hold up. I keep having to compete with people talking. You want to get some colors, but your group can share colors. If you want colors that match the physical colors of the tile, you want blue, purple, and green. So if you want colors that match the tiles, you want blue, purple, and green. And they kind of have like a darker blue and a lighter blue. So if you want, you can grab 2 different blues. Send one member of your team up to get some colored pencils. Big box, to your left, to your left, to your left, to your left. There you go. If it was a snake, it would have bit you. If it was a snake, it would have bit you. Have you never heard that?
No.
Meaning, like, you were so close to it and you didn't see it, the snake would have bit you. I would go blue, dark blue, green, and purple. But there isn't really a dark blue here, is there? You could do like just 4 different colors. Then, please get every type of tile. Yeah, just leave that. Get every different type of tile out on your desk. If you watch up here, I will show you every type that you need. Big purple square, purple rectangle. Blue square, blue rectangle. Green rectangle. Bitty square. And connected squares. Then, now here's the hardest part of today's lesson. Are you listening? Take your pencil, trace these shapes into your notes. So hold up, I was not very specific. If you still just have that piece of paper we took the quiz on, I would get out your toolkit or your math journal or wherever you're taking notes in. We want to trace these into our notes. If I was you, I'd start with the one little square and that guy. Then I would do these. Then I would do these. And then maybe this off to the side or something. I would kind of group them similar to each other. Now, if you're using graph paper, don't, trust the squares. I would honestly do this kind of diagonal because you don't want the graph paper to goof with your brain. If you're using lined paper, you're probably fine. But the graph paper might goof with your brain. I'm actually going to get a blank piece of paper just to make it easier for me showing you guys. Now I'm going to give you a couple minutes to do this, but I'm not going to give you forever. So you guys can chat or whatnot, but please make sure you're making forward progress getting these traced. It kind of doesn't matter that much. We'll do that in just a minute. We'll color things in. Do not color these in yet. We're just tracing. Just tracing. Doesn't have to be perfect. Yeah, the corners, I always just kind of have to remove the tile and make the corners on my own. You should end up with 7 tiles traced on your paper. So I think CPM has changed what they call this a couple times. Sometimes we'll see them called algebra tiles. Sometimes we'll see them called algebra models. The pluses and minuses, positive, negatives that we've been working with, those are integer tiles, and I don't even like that they're called tiles, but these are now our algebra tiles or models or whatever you want to call it. So you should have this drawing in your book, like in your notebook, whatever you're taking notes in. Now, what I'm going to tell you is the name of a tile is going to be the tile's area. So somewhere jot down that a tile name is the area. And we're going to put that on the inside of the tiles. So when given a tile, if we write something on the inside of it, that's going to be the area of it. So if you need to make yourself a little note. Tile name is the area, we're going to put it inside. When we start measuring, counting, doing all that stuff, we need somewhere to start. And that is going to be my itty bitty square. Now, because it's a square, what do we know about it? All sides are equal, right? And this square, fortunately for us, is called the unit square. Calculate. Yep, I only took 4 yesterday because I like the 84s, but the kids like the 83s. Well, okay. Yeah, I think that's it. That and mine is good. Do you want some 84s? Yep. 25 is good. Do you need more than that? I got one more. No. You want them back? Well, 2? Yeah, if I could. I'll put it down. No problem. This is a 1 by 1 square. So go ahead and label your edges on the outside. It's length 1 by length 1, which means what is its area? 1! Woo! Yay! Now, unfortunately, if I try to line, now remember, your drawing is a bit bigger than the actual tile. This does not line up at 4. Everybody wants to argue with me that it lines up at 4. That is not true. This does not line up at all. So, by the way, this other tile, if I connect here and here, what do you think this tile could be called? What could this tile be called? 5, right? Because it is 5 wide, 1 tall. The area of this is a 5 tile, the whole thing together. That's why I drew these lines light. It's just connected. It's 5 connected tiles to make our life easy. This length is not countable. Not countable. They're being very dramatic. So, what do we do when we can't count something? We use a variable. What's the variable we normally talk about first? Oh, I saw a couple people mouth it. X, right? We talk about X first. That's X by 1. This is Y by 1. And I want you guys to investigate what are the names of these 6 tiles. What are the dimensions of them? So here's what you're doing. I'll write it out. You want to first figure out, and you can use your tiles, what are the dimensions of these tiles? So length and width. What is the name? So the area. And write that on the inside. And what, and this is kind of the, like, if you get there, what is the perimeter of the tiles? So try that out with your teams. Dimensions, name, and area. Or sorry, dimensions, area, and perimeter for all of these tiles. None of the tiles are countable, except for the 1 and the 5. So quit trying to compare. It's not 3 or 4 or 4.2. You cannot count it. That's why we use X and Y. Remember, you're drawing slightly bigger than what the tile actually is because you traced it. You traced, can't measure it. It's not countable, not measurable. For all you know, the world that these tiles live in don't have centimeters. You ever want a very interesting... Anyone watch Orville? Okay, well, so there's a book called Flatland, and an episode of Orville this past week talked about it where the different shapes have different status in society based off how many sides you have. So the triangles are like the working class, and the squares are the next up. And like, so as you get more sides, you go higher up the social status. It's interesting. But they're the highest. Yeah, because they have like infinitely many sides. So because if you get bigger, like you have 100 gone, it's going to start to look like a circle. 1,000-sided shape, it looks a lot like a circle. If this is X by 1. What is its area? What is its name? What? It's X times 1, right? And X times 1 is just X. So the name of this tile is X. But that is area when we talk about it as the name of the tile. What's the name of this tile then? The Y tile. Now this is where it gets harder. What are the dimensions of this tile? I hear people like whispering it. What were you saying, Aubrey? X. So wait, we had this tile was that, and this is the same color, which might be for a reason. It's X by X. Right? And if it's X by X, if the dimensions are both X and X, what is the area, Patrick? X times X, which is also X squared. So we actually call this tile the X squared tile, because that's a more efficient way to say X times X. So the name of that tile is X squared. What do you think the name of this tile is going to be? Y squared. Now take a moment with your group. For all the marbles, don't know what that means. What is the name of this tile? Take a moment with your group. Aubrey? It is the XY tile. You can put the multiplication dot, or you don't have to, because this dimension is X. This dimension is Y. So, let's make a little table. So, we have area for all of the tiles, which is also like the name. We want to solve perimeter, so I'm going to give you a minute, longer than a minute. So fill in your table, and I'll get you started. If I have my area tile of 1 or my area tile of 5, well, okay, perimeter 1, 1, 1, 1, what's my perimeter? 4. Now that would just be units if we have to give it a label. This 1 was units squared, if you want to remember that they're different. What about my 5 tile? What would be the the perimeter there? Grant? 12, because 5 by 5, 5, 1, 5, 1 gets me 12. So you want to fill in this table for your x tile, your x squared tile, your y tile, your y squared, and your x, y. Take a couple minutes. If you can't agree on one, move on, and we'll come back to it and check it all together. Oh, by the way, at your leisure, please don't make this your focus, but you could color these in to kind of match the tiles. So since my x and x squared were kind of this blue, if you want, and you don't have to color them in, but if you want to color it in with like a light blue. And just do it super fast. Do not be technical with it. Make sure that you don't shade them in dark because we want to see the name of the tile. Take about another minute. Try to figure out these perimeters. Now, if certain things are not countable and other things are, we may not be able to combine them. So, here, I'll give you a hint with like the X tile. If I take a walk around the X tile and I go a distance of 1, then I go a distance of X. I've gone around half the tile. How far have I gone? What do you think, Zoe? How far have I gone? Can you use a number to say it? Well, I've gone a 1 and then a 1x, but is a distance of 1 and 1x the same thing? No, not well, and I don't know, because I don't know what x is. So I can't add those. So we would just say I've gone 1 and x. So I go around the whole tile. Give me your eyes for a second up here on the board. I go around the whole tile and I go 1 and 1. So these two 1s add up to 2. And an x and an x, I have x plus x would be what? Not x squared, that's x times x.
Oh, yeah.
X plus x, how many x's do you have? 2, so you have 2x. So my perimeter of my x tile is 2 x's and a 2. We got that because we did x plus 1 plus x plus 1, right? We added up all of this. My x's added together and my 1's added together. So we get 2x plus 2 as the perimeter. Now if I go look at my x squared tile, I travel in x, I travel in x, I travel in x, and I travel in x. How far have I gone? 4x. So actually this is easier. Do the y squared, and xy on your own. Try to get that finished. We got about 5 minutes left. so demanding. Sorry, I kind of Any volunteers to talk me through the perimeter of Y? Something is disconnected. Any volunteers not Grant? Sorry. Let everybody know that you know what you're doing. Alright, making me pick people. Nathan, what do you think, man? If I travel on the Y like I traveled on the X tile, so if I start like here, I'm going to go 1, and then Y, and then 1, and then Y. What do you get when you combine those? So right here, perimeter of the Y tile. Can I add the 1 and the 1? Yeah, so what do you get for that? 2. Can I add the Y and the Y? What do you get? Not Y2. No. Y plus Y gives you 2 Y's, right? If I have a Y and another Y, like apple plus apple, I have 2 apples. If I have Y plus Y, I have 2 Y. So this becomes 2Y plus 2. We still got a couple minutes. I don't know what they're doing. Y squared. They've already had this lesson. We just hang out. Y. Hey, don't pack up. We're not packing up. Y squared. What would be the perimeter of Y squared? Yeah. 4Y. Thank you, Ella. Because it's Y plus Y plus Y plus Y. Now XY. Grant, we'll come back to you. Careful, that's not how we write it. You're close. 2x plus 2y. Now put your algebra tiles back in the bags, but then you may leave them on the desk. Put them in the bags, but then you can leave them. Send one team member. We still have 2 minutes. Send one team member up with your colored pencils. Please try to zip the bag so we don't have a mess of tiles. This is why I just told you to get out 1 of every type. Then, once your space is clean, check the floor for tiles, and then head out. Have a good day, guys.